Hi, I am online Skype tutor engineer Muhammad Rizwan. Welcome to my YouTube channel. In this video we show that limit of x square into sine of 1 upon x is equal to 0 as x approaches to 0. Now we start our video. As we know that x approaches to 0 means that x is very close to 0 but not actually 0. If x approaches to 0, then we can write that x is not equal to 0, or we can say that x may be greater than 0 or x may be less than 0. Here if we make a 0 on real line, then value of x may be greater than 0, 0.1, 0.01 or anything, and value of x approaches to 0 may be as minus 0.1, minus 0.01 or anything. Now we take two cases. First case, x less than 0 means we will approach x to 0 from left side. And here we are taking x is equal to 0, as we know that relationship between absolute value of x into sine of 1 upon x is always less than equal to positive value of x. Here we are taking x is negative, here x is negative, so for making positive we are multiplying minus to x, as we know that relationship between two positive quantity is always less than and equal to. As due to absolute value this is always positive, but here we are taking negative value of x, so we multiply it to minus, so relationship between them is always true. So we can also write above in simultaneous inequality as we know that if absolute value of x is less than equal to c, then we can also write this as we write minus c, and here we write positive c, and we make it a middle function. So we can also write this also in simultaneous inequality as minus will be multiplied to minus and it will become positive. Now we multiply previous equation to x. We're multiplying by x to every expression of inequality. So we multiply it by x because we want to make the middle function in required form. We want to find the limit of x square into sine of 1 upon x. So for this purpose we multiply the every expression of inequality, previous inequality, by x. So we get this simultaneous inequality. So if we also know that if we have a less than x, a greater than equal to x, x greater than equal to b, then we can also write this as a less than x equal to x and x less than equal to a. So we change this in less than sign, less than and equal to sign. So as we know that our x is less than 0, so we can apply left hand limit. We approach to 0 from left side, so we take left hand limit. X approaches to 0, and this minus shows left hand limit. So x approaches to 0 from left hand side. So we can write, we take this limit and we find the limits of smaller. This is smaller function, this is a greater function. We find the limits of smaller and greater function. Limit of smaller function minus x square is equal to 0, and limit of greater function is x square is also 0. So by squeeze theorem we know that if the limit of smaller function and greater function is equal, then we can write that the limit of middle function is also equal to the limit of smaller or greater function. So by squeeze theorem we have calculated the left hand limit of our function x square into sine of 1 upon x is equal to 0. So left hand limit is equal to 0. Now we take other value if x greater than 0. Now by using this we will approach to 0 from right hand side. So we know that as it is always positive, and now x is also positive. So relationship between absolute value of x into sine of 1 upon x is always less than and equal to x. We can write by using this, we can also write in simultaneous inequality minus x less than equal to x into sine of 1 upon x into less than equal to x. So here we need x square. So for this purpose we multiply every expression of the inequality by x. So we multiply this to x, and we multiply this expression to x, and we multiply this expression to x, because we want to find the middle function in our required form. So we are multiplying, after multiplying we get this x square, not x, and here we get also x square. Here we also write x square, and we apply limit x approaches to 0, and this positive shows that we are taking right hand limit. We are approaching to 0 from right hand side. So we are taking right hand limit. This positive shows that we take the value of 0 as 0.1, 0.01. We are taking this limit. This is our smaller function, this is our greater function, and this is our middle function. So we find the limit of smaller and greater function. As we know that limit of minus x square is equal to 0 as x approaches to 0 from right hand side. So limit of greater function is also equal to 0 as x approaches to 0 from right hand side. Or if we take the right hand limit of x square, then it is also equal to 0. So by squeeze theorem we can write as our smaller function limit and greater function limit is equal to 0. So by squeeze theorem we can write the limit of middle function is also equal to the limit of smaller or greater function. So in this way we have calculated the right hand limit. As our left hand limit and right hand limit are equal to 0, so we can say that when left hand limit and right hand limit becomes equal, then we can say that our limit exists. So left hand limit and right hand limit both are equal to 0. So in this case we can say that limit of x square into sine of 1 upon x exists as x approaches to 0. So we can write limit x approaches to 0, x square into sine of 1 upon x is equal to 0. This is our required result. Thanks for watching my video. If you have any question, any confusion, you can message me on my Facebook page. You can also contact me on my Skype ID. You can also call me or message me on my WhatsApp number. I will try to help you. Thanks for watching and listening my video.